Hello everyone and welcome to today's webinar. On the behalf of the American Petroleum Professionals of Iranian Heritage, APPIH, it's our great honor to start another Spectrum session on the subject of the physics meets data science, a journey into energy technology ventures. In this Spectrum series, with the help of the senior in the field of oil and gas, we try to talk about the spectrum in the oil and gas field. Today's session will moderate with Mr. Farrokh Pebdani. Mr. Pebdani is a graduate of UT Austin and Louisiana State University with BS master degree in chemical engineering. He worked for ExxonMobil International for 20 years and retired in 2000. He worked for Aramco for 10 years in reservoir management and research. In 2012, he founded a consulting company based in Texas entitled Reservoir Transformation Group and has been working mainly in the field of field development planning in the Middle Eastern fields. For more details, you can look at to his LinkedIn profile. I would like to thank Mr. Pebdani for accepting our invitation. Before starting, two short points. First, during the session, you can write your question in the chat box, and please switch off your microphone and camera from now. And the second, a recorded version of today's webinar will be available in the APPIH social media. Without further delay, I'm transferring the microphone to Mr. Pebdani for starting today's session. Thank you.
Thank you, Hamid. I appreciate all your effort in putting APPIH on the map. You've done an excellent job. I appreciate that. Today, I want to take a different approach in these webinars that we've had. I have invited Dr. Cedric Fraces, who's a PhD candidate and almost a PhD from Stanford University. I've known Cedric for a few years, and he has a spectacular career. He has worked for the largest service company, one of the largest international oil companies, and also one or two national oil companies, again, all the big ones. And then he has switched career, and now he's an entrepreneur. Also, he's an immigrant. I thought what he has achieved is something that a lot of our young people that are members of the APPIH would like to hear more about. So with that brief introduction, Cedric, I want you to give a 3 to 4 minutes bio of yourself, and then we go to the second stage of this webinar. Please go ahead.
Thank you, Farrokh, for the great introduction, and thank you for the invitation. It's a great honor. So a bit of background about myself. So as Farrokh said, I'm a PhD candidate at Stanford. About 3 years ago, I decided to leave Houston and move to the Bay Area to start this PhD. And prior to that, I had spent a bit over a decade working in the oil and gas industry as a reservoir engineer, as a production engineer, and also what was starting to emerge as what we call like now a data scientist. There was no name for it at the time, but what we started witnessing was like with the emergence of massive influx of data and new algorithms being made available by like the big technology companies. We started to see kind of a space for the application of such technologies, and that was kind of my gateway to what we're going to discuss today. So across my career, I visited and I had the chance to work, as Farrokh said, in many countries. And we met as we both were working in central China about 4 or 5 years ago, maybe more than that, 6 years. And so during this career, I had the incredible chance to working on projects that were very challenging technical problems with also very huge societal impacts. So from the production of the largest fields in the world in the Middle East to the managing of the portfolio of entire states, countries, oil producing countries. I also worked on the first industrial scale carbon sequestration project in the US. And so during that time, as I said, I was developing an interest for forecasting method uncertainty and decision under uncertainty. And I started working on statistical method, but then quickly figured out that I needed to educate myself a little more. And that's what led me to the Bay Area. And as I started my PhD, I was also interested in entrepreneurship. As you know, this is a very favorable environment for the emergence of startups. And so that's where kind of the idea of Tenokonda emerged with two of my partners that I introduced a bit later today.
Can you briefly tell us about your very early start in the service companies?
So yeah, one of my first positions as I graduated from with a master's was working with Schlumberger, which is one of the largest service companies. It was I spent the first 4 years of my career there. It was a fantastic experience, both from a learning standpoint, understanding all of the aspects of an oil field. From drilling, testing perspective, also understanding the various technologies that are developed by these service companies, software and hardware technologies. And this is also where I worked on a project on carbon sequestration. And that was an interesting 2 years where I got to travel to various locations in North America where this field was kind of very experimental at the time, but there was quite a bit of interest. And I feel that this is something that has become relevant again recently with the need to provide more sustainable and carbon neutral technologies. And those are coming mostly from the oil field, which is interesting, right? So when you talk about those things, the oil companies have been pioneers in the introduction of those technologies.
Great. I understand you also had a chance to work in Total briefly. Can you tell us, comparing working in the service company Schlumberger, IOC, Total, and then NOC in China, Iraq, and Kuwait, which experience did you value the most, and which was more fun, if you want to look at it that way?
Okay, so there are two aspects to it, I guess. It's very hard to say that one experience is better than the other, right? But I think I'll probably try to think in terms of learning experience and also in terms of impact. And I guess, fun is probably a big part of the idea as well. So I'll touch on that. So I'd say from a impact and from being able to have space to try things, working for an NOC is probably the most enriching experience, because the biggest asset belongs to NOCs. Day to day, they have to take decisions that impact thousands, tens of thousands of barrels of production. And it's very rewarding as a young engineer to be able to see immediately actions being taken on recommendations that we make and see those turn into increase in production. From the IOC, I think is probably the IOC experience provides the most cutting edge in terms of providing capital efficient techniques, right? IOCs don't have the same luxuries as NOCs. They have to be competitive, they have to be capital efficient, and they are very cut to the chase and pragmatic. So that's where you implement solutions that have to be very competitive with the other companies that you're going against on every bid, but on top of it have to have application right now. So it's not like just science projects. And then the service companies is where your only asset is really your technology. So you have to make it, you have to showcase it, and I think that's where I learned the things that went the deepest into trying to have technologies that are cutting edge again, that make you very competitive. So they're all different, right? And I think overall a career in the energy is fun because, you know, at the end of the day, 15 years down the line, you have a ton of stories to share. Every time I see Farrokh for dinner, we'll go over some of those stories. And I think that's really unique in terms of an industry, right? People work in computer science might work on a very cool AI project, but I can guarantee that they don't have a tenth of the stories that we tend to tell to each other when we see each other.
Okay, in terms of training and development, where do you think you get the best training and development? IOCs, service companies, or NOCs?
So I think, as I said, it depends on the type of training you're talking about. So if you're talking about so I remember working at Schlumberger, the training before, the preparation before you went on the field was probably the most comprehensive. So one of the mojo was to say, do it right the first time. So you don't have the luxury to go try things, mess it up, and somehow learn on the job, right? Although your peers are going to provide a bit of a sandbox for you to make a little bit of mistake, you don't have room to do that kind of stuff so much. But then the on-the-job training, the part where you essentially have the luxury to make a bit of mistakes and learn from them, where I was given the most freedom was working for NOCs, because that's where, again, the bulk of the production is happening and where people are just striving to try new things. So they're very receptive to new ideas. Different countries obviously have a different appetite for new ideas and risk. But working in China, for example, was extremely rewarding because there was again, like an effervescence and a very positive mindset when it came to trying new ideas.
Okay. Now, I had one last question on financial rewards and future, but let's skip that one. Let's go to, you changed career. You went back to school, to the university to work on AI and machine learning. Just give us one brief introduction, why, what caused you to change your mind from the classic petroleum engineering to go into something totally new, and then talk about your entrepreneur company that you have developed, started, and introduce your company, please.
So every time you take such a drastic decision, I think it's not like a single reason, but they're like a convergence of reason why I decided to leave that world to kind of embrace a new career. Well, the first one, I guess, is kind of personal. I met my wife and decided that, you know, leaving such a life where you were traveling all the time in countries that in some cases were not that safe, that lifestyle was not really compatible with our vision of a family. So I'd say that's probably the main reason, although everything that happens after is essentially what you make of it. So the reason why I came to Stanford, I guess I always wanted to, as I said, explore a little more that the modeling aspect of the work, understanding a bit more what was happening in like statistical learning and artificial intelligence. And I felt that I really needed to have an in-depth education about that, because a lot of things were happening out of buzz. People were just pretending to do a whole lot of things. I mean, just like 2 years ago, you know, just putting AI on the brochure of your company guaranteed that you're like getting funding from all of the biggest VCs, and every company had like a crazy appetite for it. So I wanted to kind of remove all that noise and really get a bit of a more like peaceful and deep understanding of what was going on. And the entrepreneurship aspect kind of came naturally. I think that's, I identify across my career a bunch of areas where I saw a gap. I saw that there was definitely from a human resources perspective, a huge transition happening on what I would call more generally than AI, like a digital transformation, and that the new subject matter experts would have to have a very strong background in like a quantitative background in programming and coding and mathematics. And so this is where I felt that, yeah, a PhD was probably the best way for me to get there.
Okay, please tell us about how you started your new company, and then go through the presentation that you have prepared.
Sure, so I'll probably go through that when I present, but essentially the idea, we have been in discussion with my partners for like years. I've known them for decades now, and we've worked together, we've talked about it. But I guess things kind of got accelerated when I moved here and when I started working on those problems on my own. And I guess what happened is the three of us had formed an entity, a company on our side, each on our own way, and started by doing some consulting, which is kind of the natural gateway because it's the easiest way to be relevant and essentially find people who want to buy what you have to sell. But very quickly we transitioned towards something that was going to be more software oriented, and then decided to join forces about 2 years ago and started working on Tenokonda. So
you have a black box that you can share.
Sure. I'll try to make the black box as
okay.
transparent as possible. Can you see?
No, we cannot. Hamid can help you.
Give me 1 second.
Share slides.
Yeah. I'd like to just share my screen.
Yeah. Mm-hmm.
Okay, can you see my slides? Okay.
Right.
Put that in presentation mode.
Yes, perfect.
Okay. So first, the origin of Tenokonda. Everybody asked us, why did you pick such a weird name and what does it mean? I think there are various explanations, and if my partners were on the call, they would probably laugh at me. But the true origin is a Japanese word that means elaborate. And so you'll see, I didn't really pick the name. I kind of joined in it, but it makes a lot of sense when you look at the fundamentals and the values of the company, which is to really focus on the science, focus on the solution that add value through elaboration. No solution is simple, no model is simple. You have to kind of strike the right level of complexity, not make models too complex, but you know, make them superior to the status quo. And so what we do is we provide quantitative and machine learning software products, and I insist on the word software products, focusing on capital markets and energy, which are the two industries where we're coming from and where we saw a lot of synergies as well. And some of our, I'd say, fundamentals that we try to add value from day one. We don't engage in long effort, and we want to have make sure that our client kind of see the impact of what we do very rapidly. So this is why we have a set of off-the-shelf solutions, software solutions that we propose to our clients. We do not, I mean, our solution don't have an implementation overhead. They are a proven track record. They're being implemented by all of various customers of ours. And they're all relying on strong technical expertise and a very pragmatic approach. And again, going back to the question that you were asking, Farrokh, the pragmatic approach is very important. So we don't do science for the sake of science, and we don't use a technique just because it sounds cool. We use a technique because it's the best and it beats the state of the art, and it adds value.
Okay.
So the founders I've been talking about, so there are two brothers on the side and me in the middle. So you heard a little bit about my background, a little bit about theirs. Adrian is I think what I would call an expert in machine learning with obviously an emphasis on quantitative finance. So he spent most of his career working on software development for the finance industry, and started very early on working on machine learning, deep learning, natural language processing, reinforcement learning, and he has, I guess, the most comprehensive understanding of all of these methods. Dennis on the right has also an experience that is coming from the finance industry with, I'd say, more traditional method, focusing on uncertainty quantification, stochastic simulation, and essentially building a probabilistic framework to run scenarios. Both of them have a very strong background in software programming. And I guess that's kind of where the complementarities are coming from. I have more of a background on industrial project and physics, and a little bit in consulting as well. And their background is a lot more centered on coding and software software programming. So we have worked on various projects in the past, and we found out that there was again, a synergy between the two industries, the finance and the oil and gas industry, in the sense that you needed to make that decision-making under uncertainty was a bit at the center of everything, and that you needed to have the ability to build solutions that were, again, very powerful, but also be able to communicate them with decision makers. And so this is why we formed the company. But essentially what you see is that all of us have a very, I say, strong quantitative background. That's kind of the common DNA. And so on top of that, this is kind of the team that works with us. So you see a bunch of young faces here, and the background of all of these people. I haven't put like the whole company, but the quantitative side of it. I say that everybody at Tenokonda is a quant. And what I mean by that is like someone with a quantitative skill, someone who is able to code. And so we have people who are more in the research and development side of coding. And you have people who are more like in the application side, on building software solution and like user interface. But like the prerequisite is that you need to have a strong coding background. And then if you complement that with another field, whether it is reservoir engineering for the people in the energy, or finance, or deep learning, or optimization, it is also something that we value. A summary of kind of our footprint. So the people that you saw are spread in various regions of the globe. I am myself located in Palo Alto. We have a presence in Houston, New York, and then in Europe, in London and Madrid. I mean, all over the UK, but with a strong presence in London. And you have a list of our clients here, some of the largest ones. We have worked also with smaller company startups, but I haven't listed them here. And so they're coming mostly from the finance and from the energy industry, as you can see. So a word about our technology now. thing that we do, I mean, it's kind of fourfold. As I said, all of the solutions that we make have a very strong R&D component. So we're not your usual software company like a typical, I say, IT shop that is going to build front end to you. We are really focusing on the science of our solution. And so we build solutions that essentially tackle a very niche market where the state of the art, the existing solution out there, whether they are freely available or being built by competitive companies, are not satisfactory. And so when we identify a gap, we essentially build a solution that answers to that gap. And so the way we operate now is very low overhead. What we have witnessed is that there is the emergence of very open, transparent software libraries being built in the Python language. And where in most of the case possible to access the source code upon delivery. And so we work with very little overhead. Depending on the solution that you get from us, you again have access to the source code. You can audit it. You can try to understand how the solutions are being built, and it provides a much more trust with the client that we are not, again, providing a black box solution, right? The time to market down there is really like the ease of integration. So we witnessed essentially a transition in that sector, in the software sector, where back in the days it was like 90% was of the solution of the software solution was decided by the platform that we were going to use, and very often concerned the front end or the architecture of the solution, things that were not really why you were buying the solution, what like the added value in terms of decision making, in terms of insight that the solution was providing. It was mostly a fresh front end and switching from Java to a .NET. And so with the emergence of Python as kind of the data science main language, we saw that this was being a bit displaced, and that you could, with very low overhead, build what we call Python packages or libraries that you can install very easily, like with a line of command, and with like a very clear documentation, you are ready to utilize them. Then the front end that you build on top of it can completely be separated and be designed for purpose. We think that more and more it's becoming easier to customize those front end, and they can serve different stakeholders, whether it's going to be the general manager of a big international oil company, or one of the subject matter expert that is doing an analysis day to day. They're going to obviously have different needs, and we don't think that they should have the same front end. And the good news is that that back end that you have can serve both of these stakeholders. And so everything that we do is also platform agnostic. We have a Python development kit with very standardized interfaces and a very well documented API. So the solution that we have can be essentially brought out of the box from our quant library and really adapted like upon need. So if you have a need for an optimization library or a deep learning library that is going to do signal detection for anomaly detection or forecasting some time series, you essentially purchase that component. You don't have to buy into all of the overhead and all of the things that are not necessary for your business. So here I have an example. I wish I could like kind of share that, but this is one of a project that we have been working on over the past few months. But all of you are aware of the global crisis that we're facing, and what we witnessed is that there were like data sources that were available from different websites, but none of them really provided kind of the time component and really the metrics that we were interested in. So we built a dashboard that would allow anybody, and we put that online for free, to allow anybody to track day to day the number of cases in the region that they would be interested in, and allow to compare countries with each other as far as like the most important metrics, number of cases, number of deaths. So if we have time at the end of the presentation, maybe I'll give you a more thorough demonstration, but this is available for free, and this is the URL at which you can access all of this dashboard. Now I'm going to jump into a couple of case studies that are specifically applied to the energy industry. So one of them is our exploration optimization library. And so I'll explain again, if we have time, I can give a live demo of this. I'm not a big fan of using PowerPoint. It's a bit static, but yeah, I guess we can revisit that a little later. So the
You
problem
have time. Take your time. Take as much time as you want.
All right. So the problem that we're tackling here is so when you're looking at exploration bits, you're going typically into certain blocks, whether you're onshore or offshore, and you're trying to understand a little bit how the subsurface is looking, right? So there are different risk factors that characterize the subsurface and how they are correlated. And so you're trying to essentially maximize your return by adopting an optimized investment strategy for your portfolio. And typically, the type of decision that you have when you go into a block, if you already have some prospect that belong to you, is the option is to buy, to divest, to develop, and to partner, right, with some third party. And so what you can view this problem as is the problem of investment portfolio optimization. And this is something that people in the finance industries have done for years. So understanding the various risks, understanding how correlated they are, and the dependency structure between all of these different risks, and maximize their return and minimize their, maximize their return for a level of risk. And so typically the framework that we use is the framework of modern portfolio theory, which is the theory that was brought up by Markowitz, and that essentially states that optimum portfolio is a portfolio that sits on the efficient frontier. So if you look at a plot that looks at the value versus risk, so value in the y-axis versus risk on the x-axis, a portfolio is deemed efficient if no other portfolio has a higher value for an equivalent risk, or lower risk for an equivalent value. So they sit on what we call the efficient frontier here. And so the whole idea here is like, how do you cast a problem of typical subsurface like exploration, block exploration on a financial decision like problem. So the solution that we came up with is the exploration optimization library that provide that unified framework where you could look at the different blocks and the different prospects. You could look at various levels of correlation. So you could just simply say that all of the blocks are completely independent and uncorrelated, which we know is untrue. You have underlying reservoir structure that correlate blocks. If I find oil in this, and I know that there is a trend, you will very often increase your chances of finding oil somewhere else. And so the idea is to understand what combination of this portfolio provide the highest return for the lowest risk possible. And so ranking those opportunities using cumulative distribution or S-curve is a very useful tool for decision makers. So the features of this library are that obviously this calculation has to be fast. You're supposed to understand if I choose to go into 1, 2, 3 of those blocks, what is the potential resource or reserves that I'm going to tackle, and what is going to be the risk associated with that, based on assimilating again all of the data that I have, and being able to simulate the different variables. Quantifying the codependencies on the risk, and being able to run what if analysis, right? What if I decide to acquire this portfolio, this block, that block, and that block? What does it look compared to, looking at the different combination? And so each of these dots here represent essentially one of the portfolios. And you can pretty much compare them. Again, looking at this is probably going to be a combination of like 2 of your prospect compared to all of the portfolios that have a lower amount of value for the similar risk, right? So that's a useful tool for decision making. We'll maybe get in a demo a little later. I don't know exactly how I can share the screen, so I'll have to figure that out. So another case study is the utilization of Bayesian network for exploration scenario analysis. And so how do we do that? And the first thing is what a Bayesian network, a Bayesian belief network, probabilistic graphical model are. They are essentially what we call a category of directed cyclic graphs that allow the simulation of joint distribution. So this is a bit of a mouthful, but what it means is that it allows to simulate variables that are have a dependency structure. With the example, is going to become very clear. So let's imagine that each of those A, B, C, D, E is a prospect that you're trying to drill within a block. And so for each of them, you have to account for various risks. The various risk categories are the typical geological risk factors: the source, trap, reservoir, charge, and seal. And you represent them here: the seal, the source, the charge, the reservoir. And you can also have commercial, operational, and technical risks, such as the potential recovery. And so as you see, these different risks can have a nested or layered structure. So the seal could be related to the integrity of your trap, or it could be also related to the continuity of your trap. And those obviously have a dependency with each other, and they're all impacting jointly what is going to be the probability that you're going to encounter a commercial amount of oil at a given prospect. And so why do we think that this type of framework, that Bayesian framework, is very interesting to resolve that kind of problem? Is because typically Bayesian network are a very, very powerful integration knowledge tool that allows to capture both hard data and measurement, but also heuristics or expert knowledge. And that goes back to kind of the theme that we were talking about like physics meeting AI and data science, is that the Bayesian framework is essentially trying to reconcile a prior knowledge that you have about the chance of something occurring and the evidence or the observation that you do on the posterior. And you just have to constantly update or calibrate your understanding of the reality of the world based on the evidence that you're encountering. And so this is, I think, a very strong and elegant way of solving those problems for various reasons. The first one I just mentioned is that you can, with very little data, by understanding essentially that, I don't know, your seal is going to obey a certain amount of rule, but you can start with something as simple as hypothesis. If my seal has a low integrity and I have a good quality reservoir and my charge is high or low, and I don't know, where I have like a filter spill, and my source rock is abundant. What does it mean for all of these different prospects? And so without data, you can already like combine those different rules and say, and start forming hypotheses and exploring some different scenarios. If you start having observations, so analog data, if you start having like some core, some log measurement, and you understand kind of the log a normal distribution of your different reservoir properties, you can essentially populate and have more precise distribution there and rerun these this tree and have an update in all of the quantity of interest, right? So the in this case is the oil in place that you're going to encounter for on each of these prospects. And so the next thing is that if you happen to drill one of these wells and encounter a certain amount of oil, you can essentially update based on a certain evidence your understanding of the different priors and see how that new proof, that new evidence is propagating and updating your understanding of the world. So it's a very good, again, data knowledge integration tool that captures the causality relationship between variables, right? A big down point on artificial intelligence, on machine learning especially, is the absence of interpretability, the absence of causality. And this is kind of the million-dollar question: how do you know that your algorithm is giving the right solution? Is it because you just trained it and you trust it? You have no way of knowing that. And with this Bayesian framework, you have a way to trace that causality, right? Not just correlation, but causality. And then you can also use this, they're a very powerful tool to quantify value of information, right? So which of these prospects would give me the more information about all of the others based on what I see and how these different codependency structure is being built. So you can start just by drawing the diagram, understanding how things are related, and then understanding which of the prospect has the highest value of information. And so this is also very useful, right? Buying or acquiring a log is going to cost me a couple $100,000. Is it really worth it in view of the potential amount of oil that I would be able to unlock, right? And then simulate scenario and decision tree. In that case, we built that for you were interested in what was the optimum drilling sequence, right? Should I start with A? Should I start with C, D? Which well provides the most information again? Provide the highest potential for unlocking resources. And so in view of that, you have to simulate all of the possible paths using decision trees. And there is a very good way with dynamic programming to kind of do that exhaustive exploration of path. So these are two of the examples. This is inspired also the solution from an SP paper.
How many more examples do you have? I really would like to see that COVID-19 demo because I think it's very relevant for the times that we're in.
Okay, let me try to do that. So,
do you have any more examples you want to show, or was that the last one?
So no, that was the last one. We can go into a live demo. So if I'm just wondering, can you see the web browser here? Or you're still on the presentation?
No, it's in the presentation. You should again try to share a screen and select your browser.
Yeah, I couldn't really see the share screen.
Okay, can you see that just a green sign? Okay, you can again share this screen and this time select actually your browser.
Yeah, let's do that. Okay.
Yes.
Can you see that?
Yes,
yeah.
You can see now.
Okay, so this is a map of like that was starting at the beginning of the year, where you see an evolution of the disease, right? So you saw like how it started in China, and the color coding is in yellow. You see the number of cases, in green recovered, and in red the number of deaths. And so, here you see a 7-day rolling average of the number of daily cases and number of deaths. What we saw is like over the months, like what happened with like Italy, Spain, and then the US kind of taking the lead, the sad lead on the number of cases and the number of deaths. So what you can also look at, right, it's a comparison of the different countries. More recently, you saw that Mexico, India were also the countries that were showing the highest progression. And so you can also pause at a given time, and for a given country, let's say the US, look at the number of daily cases, right? So you see kind of the two humps here with, like, in recent days, an emergence of the cases, especially in the south of the southern states, like in Texas. And you can also go back to, I mean, look at like a comparison of different countries, look at the number of deaths, where you have like a spike, just like I think the New Jersey, like new reporting of death, right? And so, yeah, you can pretty much like navigate this, go country by country and look at the number of cases. You can rank them by number of cases, but you can also look at this relative to the population, right? So in terms of population, the country that shows the most cases, you can switch back to the number of absolute values. So this is live, it's updated, and it's like every few hours, and it's taking data from various well-known sources, right? So from Worldometer to WHO and BNO and the various governments. So I don't know, maybe you're interested in seeing what's happening in Iran. There was also like a sudden increase. You can switch to a more dashboard type of view where you're looking at these different numbers and comparing again the rolling average. So looking at the trajectory of these countries compared to each other. You can again switch back to the map view and see how these things are evolving at a good time. Is there any question there?
I was thinking if there is any value to put this link on the APPIH website. That we leave that to Hamid to decide. And there is a lot of applications like this on COVID-19 and its development and its progress, but another one won't hurt to have access to. Anyways.
Yes. So it's available on our website. You can just go to the COVID-19,
okay.
Or you can just access it.
Yeah, we can have a link to your website. That's what we can do. Okay. We only have 10 minutes left. I'd like to finish by 8, so I'm going to ask you a couple of questions. What is the future of AI in the petroleum industry, in your opinion?
So I think that we went through, a typical curve of hype, kind of coming down. What I think is the biggest value of AI, I kind of have two areas of application besides all the buzz, right? Because about, again, 2-3 years ago, everybody was talking about AI as, you're going to automate everything. So you'll have self-drilling wells and you're going to retire all of the SMEs. This was obviously completely misguided. But nonetheless, I think that there are two areas where AI is going to bring significant improvement. The first one is in data assimilation and uncertainty quantification. So what we see is an explosion in the amount of data that is available now. Buying a sensor, acquiring data has become so cheap that you are like essentially monitoring your field rather than just trying to infer based on your intuition. And so being able to address that, to capture all of that data and to update your models through data assimilation workflow, what AI is providing essentially is a way to do that calibration very efficiently and to assimilate a very large amount of data. And so I think that new engineers will have to be well versed, the same way they were very good at, doing a Kalman filter 10, 15 years ago. Now they will have to understand what a neural network is, how you train them, and how that can help you absorb a lot of data. And the second area where I see a lot of improvement is in what we see is the emergence of what we call physics-informed AI. So AI itself, machine learning without prior knowledge, without physics knowledge, has two drawbacks. The first one is that you cannot interpret it, and the second one is doesn't extrapolate very well outside of where you're training it. So you have the data set, you train it, but you don't generalize well. And so when you instill a bit more physics into it through various methods, and I think I went through some of them, you suddenly have model that you can generalize now. And if they haven't seen an example, they're still able to provide an answer that makes sense to an engineer.
Okay, there are some questions. Hamid was going to ask him, but I can see him. One is, why do you prefer to use Python?
It's not, I mean, the Python has just imposed itself as the language of data science. It has become so generalized and ubiquitous that, and I think the drive behind it was that all of the big technology companies, Google, Facebook, Microsoft, essentially had a huge dumping effort on democratizing it. And so it has the largest user base in the field of, again, doing quantitative library. By design, it's very well suited for also software development because it follows an object-oriented kind of paradigm. So you can build very elaborate solutions with it, and you see that it's the most live and most used language on the planet. So it's not really a choice of mine. It's like you look at it again pragmatically. All the companies now who are trying to get serious about data science have to program in Python.
It became its standard, basically.
Yes.
Okay, another question is, if somebody with oil and gas background and likes to switch and learn about AI, what do you recommend for the newcomers?
I think again, those companies have promoted the access to free learning so much that it's quite interesting what's happening. You can pretty much get educated on coding for free with like videos online. And if you're interested in getting like certification and getting some kind of training, it's going to cost you something like south of $500 a year, right? Which has nothing to do with you know, going back to school and paying a lot for that type of education. I think it's really, really up to, you know, informing yourself, looking at training online. You have very nice institutions like, you know, EDX, Udemy, Coursera that provide a bunch of opportunities for these people to learn.
There's a question on your COVID demo. Can you predict the future cases for, let's say, a country like Iran or US or the state of Texas, for example?
I think if I could, I wouldn't be here and someone would probably have shut me down. No, we didn't go into that space for the simple reason that having a predictive model that is going to be both accurate and that you're going to have to update is extremely difficult. It depends on political decisions. It depends on a lot of factors that are very hard to predict, right? Understanding what you know, the US government is going to implement in terms of social distancing rule, you would have to be you know, divine to understand what is going to happen. So we didn't really get into that space. We focused on the data and kind of let data scientists access this. We're going to provide an API to download all that data as well, and they can then build their own models.
Okay, I'm sure you remember recently, a few weeks ago, maybe a month ago, Google announced that they will no longer develop tools, machine learning tools and AI tools for the petroleum industry because of the environmental issues Do you think that really has an impact on the industry? Or companies like yourself, Beyond Limit, and there are a few others, are those companies able to do what Google has refused to do so in the future?
To be honest, I mean, there is like the example of Google, I think is a bit strange to say the least, right? I'd say, I mean, Google market share in the oil and gas was just very minimal. And I feel that they kind of tried to get into that market with a bunch of oil and gas companies. And I think they just lost. And they decided that it was not a worthy investment of their time. But I was involved with companies when they were essentially proposing like bids for cloud services and trying to displace Microsoft Azure, AWS with Amazon. And in all cases, they lost, right? And I feel that it's kind of convenient now to say, oh, yes, we're very green and we're not going to do it. I think it's a bit misguided for various reasons. The first one is you don't vilify a whole industry just like that. I think when you look at what the energy industry is doing to become more sustainable, if anything, you should help them more. You should be in there and try to modernize them and to influence them. Not saying that there's not any work to be done, but in the case of Google, I feel that it was not entirely motivated just by being eco-friendly. This being said, we see that the ESG index, environment, safety, and governance, is more and more important, and we are very committed to that as well. I think all energy companies that are serious about development will have to show that they are moving in that space. And but again, just saying that we're going to stop to work with them, I don't think is a good solution.
Okay, thank you. I think I've covered most of my questions and some of the audiences. Hamid, if you have any questions, please ask and then turn it back to me for one last comment. Then we can shut down. It's almost 8 o'clock.
No, there is no other question. Maybe you can close and I have a chat.
Okay. One last thing. I know, Cedric, you speak multiple languages, at least 5 of them. So Chinese and English and French. I don't know what the other 2 are. Maybe someday you will learn
Spanish.
to see. So maybe you can tell, I know you're a bright guy, maybe you can tell a bit more about your diversity and being an immigrant and what you recommend for a lot of our audience will be young immigrants types here in this platform.
Well, I think that everybody who kind of follow that track like that, technology has no border and has no language, has no religion. It's a way to kind of unify people. I think that everybody who comes here in this country is kind of chasing the same dream. You and I have talked about this over dinner and more many times. I feel that there's a lot of commonality between you and I. We are both immigrants that came into this country to chase a better life, and by our work and staying honest and keeping at it, this is kind of our way to achieve that. So I feel that it's a wonderful place. I hope that it's going to stay like this. We see a lot of things happening at the top level of this country that are a bit worrisome, especially for the immigration visa. I hope that these things are going to get overturned without getting too political, and that this country is going to remain a place where people want to come and better themselves.
I'm sure it will. Anyway, I want to thank you for your time. Excellent presentation. And I want to wish you the best of luck in your new endeavor and your graduation. And congratulations on your new baby.
Thank you.
Wishing you a wonderful life. With that, I'm going to turn it over to Hamid. Hamid, please close it.
Once again, thank you.
Question, please ask.
Thank you, Cedric, for such a very insightful presentation and all the participants for taking part to this event. Just for your information, a recorded version of this session will be available in the APPIH social media by end of today. Thank you and have a great rest of the day.
Thank you.
Thank you.